Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Using Open Source Technologies to Rapidly Build Secure IoT Devices, brought to you by Tech Online, Sierra Wireless, and broadcast by UBM. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. And today's program features audience polling. There will be 3 polls within the program today. All you need to do is select the appropriate answer next to the radio button and then click the submit button. Please participate in all the polls as we would like to have your feedback. You can also participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the submit button. Please note that we'll try to get to as many questions as we can at the end of our webinar, but if we're not able to get to your question today, someone will get back to you via email. And at this time, we recommend that you disable your computer's pop-up blockers. This will allow the slides to advance automatically throughout the event. At the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events, and you can also launch the survey at any time by clicking on the red survey button at the bottom of your console. And if you're experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation. Using open source technologies to rapidly build secure IoT devices. Discussing today's topic is Ashish Sayal. Ashish is the principal IoT evangelist and lead architect of the mangOH open hardware platform. Ashish brings 16 years of embedded wireless experience and has successfully driven multiple innovative hardware designs within the Advanced Technology Group at Sierra Wireless. And joining him today is Jen Chitty. Jen is architect of the Legato open source embedded application framework, has over 23 years of embedded development experience in such diverse fields as telecommunications, distributed systems, building automation controls, and robotics. And also joining them today is Ken Arnold. Ken is a senior marketing manager and brings 15 years of embedded marketing experience from development tools and engineering services to software and wireless components. It's with great pleasure that I now turn this special session over to Ken to begin. Ken?
Thank you, Chris. All right, let me just change the slide. Okay, so complexity, cost, and time. Some of the major challenges facing IoT developers. This is nothing new to us. What is concerning is that there are great ideas out there that may never get prototyped or tested due to the inability to actually prototype the idea. And the other concern that we're facing is that there's great prototypes out there that will never become commercial products due to the time and cost involved in getting to market. That's why we're excited to introduce 2 open source initiatives to you. mangOH is a new open source hardware platform that not only helps you prototype quickly, but its design and components can also be used in final commercial product. And Legato is an open source Linux platform for building connected products. It's been tested and implemented in the automotive market and is now ready for industrial IoT products. But we know that prototypes aren't the end goal, so ultimately you need to get your idea to market before the window of opportunity closes due to competition beating you to the market or the bank account running dry. So just before we begin and jump into these 2 open source initiatives, this just gives you a bit of an idea of the architecture and puts the projects into context. So as mentioned, mangOH is a sensor-to-cloud open hardware platform that Ashish is going to walk us through. And Legato is the software stack that takes the sensor data and sends it over cellular networks to the cloud. Jen will explain that a little bit further in today's presentation. So with that, I will pass it over to Ashish.
Hello, everyone. I'm very excited to share the details of the mangOH project with all of you today and talk about how it can be used to rapidly prototype and build your IoT devices. mangOH is an open hardware reference design purpose-built for cellular connectivity. It is the first manifestation of Project Mango. It is a low-cost, highly flexible, and expandable open-source hardware reference design for the Internet of Things. It allows developers to use Sierra Wireless's CF3 modules to build connected products. Using the Legato framework, it enables developers with limited hardware, wireless, embedded, or cloud expertise to build products easily. Developers can write out-of-the-box IoT applications and connect them to the cloud using Sierra Wireless's AirVantage platform or their own cloud platform if they wish to do so. The one key thing to remember about this platform is that it allows you to develop proof of concepts faster and cheaper. You can quickly test out your ideas as well as throw away ideas that don't succeed and do it at a very low cost. Now I'm going to talk to you about how this can be done. Mango's flexibility comes from two onboard CF3 sockets. CF3 stands for Common Flexible Form Factor. Common as in common across generations of cellular technologies from 2G to 4G. Flexible as in the modules can either be soldered down or can be put in a socket. And by the form factor itself, it means that it is standardized and strictly maintained by Sierra Wireless. The CF3 socket can accommodate a smart WP module or a bit pipe HL module. These modules allow you to connect to any cellular network anywhere in the world. Mango supports a single network connection using one module or two simultaneous network connections using two modules. What this means is that you can have one connection to, for example, an AT&T network and one to Verizon simultaneously when using this platform. Using these modules allows the developers to not only connect to the cell network, but also build IoT applications at the same time. The Smart WP module forms the core of the Mango platform. It includes a telecom core that will provide 2G to 4G connectivity, as well as a GNSS connection. These modules also have an application processor with multiple interfaces like SPI, I2C, SDIO, HSIC, UART, USB, multiple ADCs, and GPIOs. These interfaces allow developers to connect to other wireless, wired, and sensor technologies. The present Gen WP application core has a Cortex-A5 at 550 MHz. It also has a 2 gigabit NAND and a 1 gigabit RAM reserved for application development. Mango allows you to use existing open hardware Arduino compatible shields. Mango has an Arduino compatible connector that allows any Arduino shields to be plugged on top of Mango. There is an onboard Atmega 32U4 chipset directly talking to the WP module. We have a pre-built Legato bridge application allowing seamless connection between the Arduino shield and the WP module. You just download the sketch that was written for the original Arduino shield using the mini USB connector, and the bridge application will take care of the rest. We can also have a two-way data exchange between the Arduino shield and any other Legato application running on Mango. We also provide a couple of additional APIs that let you push this data to the cloud, which can be yours or the AirVantage cloud platform. IoT connectors provide a new industrial-grade open standard interface to the industrialized short-range wireless, wired, or sensor technologies. Developers can write applications using IoT hardware from supporting partners. This includes a Wi-Fi Bluetooth combo module from TI, DUS module from Linear Technologies, CAN bus IoT from Microchip, Thread and Zigbee module from Talon. We also have third parties like Renfell in Australia who have already built IoT boards like RS-232, RS-485, digital IOs, etc. We're also planning to deliver other IoT connectors like Enocean, Modbus, Profibus, etc. through the later part of the year. So let's see how this all works. When an IoT module is plugged in, a Legato application looks at it and says that there's an IoT module that's inserted. This application then reads the EEPROM of the IoT connector to see what kind of module it is. Basically what this means is that it will be able to know the chipset used on the connector. If the platform supports a driver for that chipset, it will load the driver as a loadable Linux kernel module. If the user has specified an application for the given IoT module, then that particular application is run. For example, for a Wi-Fi module, you can then configure it as an AP or a client. For a Bluetooth module, you can run its appropriate profile and a corresponding application. Our long-term plan is to have an app store for such IoT application so that the end user doesn't even have to write their own applications. The key point here is that using the IoT connectors plus WP module running the Legato framework, we allow developers and companies to build industrial-grade prototypes easily and quickly. A quick note on the IoT connectors. A single IoT connector is 22 millimeters by 45 millimeters in size. On the mangO itself, using QSFP Plus connector, which is an industrial-grade connector, it can take up to 26 gigabits per second data rate. The QSFP Plus connector is easily available from most of the connector companies or through a standard distribution channel. We have a very well-defined open standard that can be downloaded from mangO.io. This standard was made after extensive discussion with our partners that include Texas Instruments, Linear Technology, NXP, Talon, and Renfell. We are beginning to see an interest from a number of other companies and the customers in adopting this IoT connector standard. The mangO platform provides 3 IoT connectors so an end user can simultaneously develop and test multiple applications. With this, I'm going to pass it over to Chris for our first poll question.
All right, thank you, Ashish. And this is the first of our 3 polling questions. To complete the poll, just click on the radio button next to the answer that's appropriate for you. So let's move on now with our first polling question. Which IoT connectors would you be most interested in? Your answers could be Wi-Fi, Bluetooth, Zigbee, Thread, or industrial, such as CAN, RS-232, or RS-485. And so we'll give you a moment to go ahead and submit your answers. Again, click on the radio button next to the answer that's appropriate for you, and we'll give you a few moments to do that. Again, which IoT connectors would you be most interested in? Wi-Fi, Bluetooth, Zigbee, Thread, industrial, meaning CAN, RS-232, or RS-485, for example. And so let's take a look here in a moment at what those look like for results. We'll wait a few moments for everyone to get a chance to answer. We encourage everyone to answer each of our 3 polls today. All right, so I'm going to go ahead and let this refresh one more time. And let's go ahead and send these on out to the audience. All right, so it looks like the total here was 61.2% chose Wi-Fi Bluetooth, 9% Zigbee, 1.5% Thread, and 28.4% chose industrial. So Ashish, your thoughts on those results?
That's as we expected it to be. I think the Wi-Fi Bluetooth is one of the most common industrial applications we are seeing. And the fact that industrial CAN, RS-232, and RS-485 is also being used as a second number, I think it makes a lot of sense because there's a lot of industrial applications which use these interfaces. So this is in line with our expectations. Thank you, Chris. Okay, so moving on to the additional features of the mangO Green platform. Some additional hardware features of the platform include 1 USB on the go, 1 USB on the USB host, a RS-232 connector that can be configured as a console output from the module, but can also be used for RS-232 communication. It also has a 10 by 100 megabits Ethernet port that can be configured as LAN or as a WAN port. mangO has an onboard audio codec. You can use this to make voice calls, record memos, etc. It also has a micro SD card. We provide 2 SIM slots and a provision for an embedded SIM on this platform. We provide a built-in battery charger. By the way, you can run mangO specifically on a single-cell lithium-ion polymer battery if you wish to do so. The input voltage for that is between 3.4 volts to 4.5 volts. The platform itself can take an input voltage of 4.5 volts to 17 volts. It also has a built-in accelerometer and gyroscope. We provide a number of software. If you go to github.com/mango, you'll find a lot of software that enable these features, and you can download that from there. In summary, the platform is extremely feature-rich with 3 IoT slots and a varied set of other interfaces, and is backed by a powerful microprocessor. The PCB for Mango Green was designed to meet the Eurocard spec of 100 millimeters by 120 millimeters. This allows you to take a Mango Green and put it in one of the numerous Eurocard boxes that are available. For the front and back panel, we have released on Thingiverse customizable 3D printable options. Once you decide what your front and back plate look like, you can easily modify the STL files and print the front and back plates using a 3D printer. The STL files for the IoT module sliders are also available for download. Mango is sold under a Creative Commons license attribution style. This is the most accommodating of licenses offered and is used for maximum dissemination. This license lets you distribute, remix, tweak, and build upon Mango, even commercially, as long as you credit us for the original creation. So going back to my original comment that this is a platform that can be used to not only quickly prototype, but also industrialize. So let's see why that is so. If you look at mango.io, under the documentation section, you will see that we provide the bill of material, schematics, and Gerbers for the latest, as well as archived Mango Green boards. The components that are used on the design are industrial grade. The layout has been done following all manufacturing rules for mass production of a unit. We also released documentation showing the test coverage. We also plan to release at the end of July all files in Allegro and OrCAD CIS. So you can actually then get the source files for modification and build your own product. A third party can download these files, optimize the design to meet their own form factor requirements, use similar manufacturing design rules as the one we proposed, or adjust as per the contract manufacturer you are using, and then use the test documentation to come up with a test plan. We believe that this whole process will help improve the time to market for customers who want to bring their cellular platform to market in the shortest possible time. As I had said at the start of the discussion, the one thing to remember about this platform is that it allows you to develop proof of concepts faster and cheaper. You can quickly test out your ideas as well as throw away ideas that don't succeed and do it at a very low cost. So now let's look at a use case or a case study of one of the companies we have worked with that has used this platform. Muji is a wearable company based in San Francisco. They obtained an early version of the Mango Green from our sales team. They then used this to develop apps for the wearable design. Simultaneously, they worked on miniaturizing the design to meet their form factor needs. This way, their software team was able to work at least 6 months ahead of schedule. The hardware team didn't have to go looking around for components as they already had industrial-grade design and manufacturing rules that they could follow. This allowed them to build working hardware and software prototype to test the market and to adapt their product to the market needs. With this, we come to our second polling question, and I'll pass it to Chris.
All right, thank you, Ashish. Our next question for you, what type of sensors most interest you? Your answers here can be sound, acoustic, or vibration, home or building automation, chemical, or energy and metering. Just go ahead and select the radio button next to the answer that's appropriate for you, and we will wait a few moments for you to go ahead and submit your answers, at which point I will go ahead and send them out, and Ashish can comment on those. So again, which type of sensors most interest you? Sound, acoustic, and vibration, home or building automation, chemical, or engineering and metering? And we'll give you just a few moments to go ahead and answer the question. This is number 2 of 3 polling questions. We encourage everyone to please respond. Wait a few moments for everyone to get a chance to do so. Okay, let's go ahead and take a look at our results. And it looks like 14.1% chose sound, acoustic, and vibration, 42% home and building automation, 12% chemical, and energy and metering got 31.3%. So Ashish, what do you think of those results?
I think it again is in line with the expectations. If you go back to the previous poll that was showing Wi-Fi, Bluetooth, and CAN, and then look at the sensors that are being asked for here, it seems definitely that's the type of market Mango is targeting, which is industrial IoT. And the kind of requests we're seeing from our viewers is pretty much the same. Okay, so now to talk about the software powering Mango Green is Jen Chitty, principal engineer and one of the lead architects of the Legato platform. Jen brings over 25 years of software development experience and has been a key contributor to the Legato project over the last few years. Jen, over to you.
Thanks, Ashish. So Legato is the software stack we're providing to jumpstart your prototyping efforts and help you get to production. Start with the 30,000-foot view of what Legato is. There are essentially 3 parts. The first part is a Linux distribution. Specifically, it's an embedded Linux distribution tailored to run on Sierra Wireless's Linux-capable modules to start with, although others have ported it to other platforms as well. And then we've enabled select security features as well. So Legato Linux is based on the Linux Foundation's Yocto project. And for those of you who are not familiar with the Yocto project, I'll give a quick introduction. In the past, SoC vendors needed to provide a working Linux distribution for their chips to be able to sell them into certain markets. Each chipset vendor tended to roll their own distribution, but this was not their core competency, and once the chips were sold, there was little incentive for them to actively maintain their Linux distributions. The result was that the Linux distro you got was often out of date, contained many known bugs and security holes, had minimal QA on it, on its drivers and packages, and you'd end up having to maintain your copy of the distribution yourself. Effectively, the SoC vendors and the SoC vendors and various Linux product and service organizations grew wiser and came together to form the Yocto project under the umbrella of the Linux Foundation. Now, chipset vendors all contribute resources towards a common goal, and everyone reaps the benefits. The Yocto project ports and validates a huge collection of kernels and user space packages on many CPU architectures, and you now have a choice of several tested mainline kernel versions to use with any given version of Yocto, and you have the option to use a long-term supported kernel, for which critical fixes are backported by the Linux Foundation for years. So you don't have to worry about porting your drivers to a new kernel or backporting critical fixes yourself every few months to stay safe from newly discovered security holes. The second part is the Legato application framework. This builds on top of standard POSIX and Linux APIs and complements them. It includes connectivity APIs and tools to make cellular easy. It provides helpful tools for building and deploying embedded applications into the field. It includes support for multiple programming languages and provides application sandboxing. The third part is the development environment. We start with command line tools that help you build your apps, configure your devices, install, remove, start, and stop applications on your devices, and debug your running code. We then add an Eclipse-based IDE, which supports most of the features offered by the command line tools, and adds graphical tools for discovering target devices on your network, managing and editing files directly on your device via secure FTP, doing symbolic debugging using GDB, and of course, editing source code with syntax highlighting and context-sensitive help. And now back to Chris for our final poll.
All right, thank you, Jen. We are on to our third and final poll, so hang in there with us for just a few more seconds. We just need you to go ahead and click on the radio button next to the answer that's appropriate for you. And your answers for today can be one of 5, it looks like. So the question is, what are your favorite languages to code in? And the answers here can be C or C++, Java, Python, JavaScript, or other. Again, just go ahead and click next to the radio button that's appropriate for you, and then click the Submit button, and this will be our third and final polling question. We'll give you a few moments to go ahead and submit your answers. And once again, the question, what are your favorite languages to code in? C or C++, Java, Python, JavaScript, or other. And we'll give a few moments here for everyone to go ahead and get their responses in. And then hang in there with us. We'll have the Q&A session coming up here shortly. We encourage you to ask as many questions as you'd like. Just go ahead and click on the Q&A icon and then submit your question. So it looks like we have some good responses, so let's go ahead and take a look at those. And it looks like 70% chose C or C++, 23 Java, 30 Python, 15 JavaScript, and 12.3 other. So Jen, what are your thoughts on those results?
Yeah, it's interesting, in particular, that Python is ahead of Java now. There's been a lot of push in the past for Java as a growing platform for embedded, but it seems that Python is really gaining popularity these days, and JavaScript as well is climbing there quickly. Not a surprise that C and C++ are well in the lead, though. Those are definitely the favorites, the longtime favorites for embedded. So now I'll move on to describing the software stack in a little more detail. So this slide shows the software stack that's running on the target. At the bottom, we have the bootloader, the Linux kernel, and the root file system built using the Octo project. On top of that, we have the Legato application framework, the bottom layer of which is a C library we call liblegato. It provides helpful APIs that complement the POSIX and Linux APIs. It offers mutexes, semaphores, and threads that can be inspected in the field. For example, you can see what threads are waiting on what mutexes. It provides kernel-authenticated IPC, inter-process communication, and easy-to-use info-rich logging APIs, memory pools, and much, much more. On top of this library are a few daemon processes that perform duties such as creating sandboxes, starting and stopping applications, cleaning up sandboxes after the apps stop, brokering lightweight authenticated inter-process communication connections, providing robust configuration data storage, performing atomic software updates, and monitoring for faults and autonomously taking action to recover from them. And of course, on the top, we have applications, which can be either sandboxed or not sandboxed. The modem firmware, unfortunately, is not open source, but it runs on a separate processor core, and we provide open source APIs to access the modem's functionality. So you don't have to worry about negotiating a license with the modem vendor. So in Legato, we facilitate rapid prototyping through a heavy focus on usability. We start with standard Linux, allowing you to utilize any Linux experience you have within your team. Then we identify things that can be tricky for people to learn or remember or get right, and add tools and APIs to make that stuff easier. Of course, we also simplify the use of modem services and Internet of Things cloud services. We support multiple programming languages, so you can develop in the language that best suits you or your problem. And all our tools have online help. So you can if you forget how to use something, or if you're using it for the first time, you can just run the tool with the -- help option to find out what it does or how to use it. Our code is open source and well commented, so if you're not 100% sure how something works, you can lift the lid and take a look for yourself, or ask for help in the community where someone else may have already lifted the lid and taken a look, or one of us, and myself included, may be listening and answer your question directly. We support both command line and IDE-based development, so you can work with whatever style of tools you're most comfortable with. And finally, we solve a bunch of tough embedded systems design problems for you, so you don't have to spend your time doing it. So now that you have a working prototype and the sales guys have gone out selling it, you need to get production ready probably a lot faster than you feel comfortable with. But you're not. Legato was designed to be part of a long-running, highly available, autonomous embedded system. We've bent over backwards to avoid memory fragmentation, facilitate remote debugging, minimize flash wear, protect data integrity in the face of unexpected events such as power failure, ensure software updates are atomic, so all or nothing, and provide autonomous fault detection and recovery mechanisms. Legato has also been developed using software engineering best practices such as top-down design, code reviews, continuous integration, tracking of defects and requirements, and industrial strength QA. In fact, we've even passed several automotive-grade quality audits. A key aspect of Legato's architecture is our focus on component-based software development, in which interface is separated from implementation, and implementations can be swapped out with other implementations without having to make any changes at all to whatever is on the other end of the interfaces. This is analogous to hardware components, where a chip can be swapped for another as long as it has the same pinout and electrical characteristics. This facilitates things like refactoring and the construction of automated test harnesses. It improves many of the ilities, that is, maintainability, reusability, scalability, and testability. But it also improves shareability. That is, it makes it much easier to share software for free or for pay, which is key to the growth of a healthy developer community. Now, a key problem facing the world today is online security. Far too often, security is an afterthought in the design of embedded systems, by which time it's usually too late to do it properly. Also, it can be very hard to get right. Very few people are experts at properly constructing a CH root jail, for example. We've designed Legato with security in mind from the beginning, including such features as mandatory access control, secure storage, field upgradability, which is a security feature because you have to be able to field upgrade if you want to patch up newly discovered security holes. And we provide support for signed and encrypted software updates and application sandboxes. Building an application sandbox in particular can be tricky. Simply using chroot isn't going to give you much protection. You really need to add as many layers of security as you can to create as many obstacles as possible for hackers to contend with. But a lot of these things can be tricky to configure, so the Legato framework does it for you. When you create an app, by default, it's sandboxed. Now, bringing it back around to Mango, as Ashish said earlier, when your board powers up, the software detects that there's an IoT connector card in the slot and queries its EEPROM to identify it. It then uses an app control API to start the app that knows how to drive that card. The app can then read sensor data and push it to the cloud, receive commands from the cloud and drive actuators, perform local analysis of sensor data, and react to events by making network connections, sending SMS messages, driving outputs, or whatever your application needs. But if it's sandboxed, it can't do anything that you haven't given it permission to do, which we believe is also key to the growth of a healthy developer community. And now back to Chris to wrap things up.
All right, thank you, Jen. Fantastic presentation. Now, before we begin with today's Q&A, please fill out the form that's opened up on your computer. If your pop-up blockers have prevented the form from launching on your computer, you can click on the red survey icon at the bottom of your screen. To complete the form, please press the Submit Answer button at the bottom of the page. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're now going to move on to the question and answer portion of our event. As a reminder, to participate in our Q&A session, just type your question into the text box located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen, and then click the Submit button. We encourage you to ask as many questions as you wish. And the time that we have left, we'll try to get to every one of them, but if we do not get to them today, someone will get back to you via email. So let's get started now with our first question. It looks like our first question is an open one for any one of the three of you. The first question is, how do I get or buy Mango?
So I'll take that question. So if you go to Element 14's website, Element 14 is selling the Mango platform. The platform itself is Mango Green, and you will be able to buy it from their website. And they also provide, over a period of time, they'll also provide IoT cards as well as other accessories that you can use for this platform itself. So I think that should answer that question, unless you have something to add, Ken, to that? Or
So just for existing Sierra Wireless customers, any of our distributors would also sell it, the platform.
All right, thank you. The next question is asking about whether or not we will have a recorded version of the webinar available, and that will be available on demand. Within 24 hours, you're going to receive a follow-up email with details and a link to today's presentation on demand. So yes, you will be able to listen to it again in the future. Our next question for you here are these two open source platforms only for cellular applications?
So I'll take that question as well. Legato and Mango, actually the way we have designed it is, going back to Mango, you have two CF3 slots. And on those, you can insert any module, so whether it's cellular or non-cellular, as long as it meets the CF3 spec. From that perspective onwards, it is not just for cellular, it can be used for non-cellular applications as well.
Yeah, and on the software side, the Legato application framework is open source under the Mozilla public license. It's available on GitHub. As I mentioned earlier, somebody else has already ported it to a third-party processor completely without our involvement. So it's truly open, intended.
All right, thank you, Ashish and Jen. Our next question looks like, hold on one sec here. All right. The idea of being able to mix and match different technologies is quite interesting. Are there other companies adopting the IoT connector interface?
So when we came up with the IoT connector interface, we worked with Texas Instruments, Linear Technology, NXP, as well as a module company, Telon, and other partners like Renfell. So the way we designed IoT connectors and we had all the interfaces was we made sure it could meet the IoT requirements for the next 5 to 10 years. And that's how we came up with all the interfaces, the size of this platform. So going back to the adoption, yes, we are actually seeing other companies build. If you look at Talon, they're building a Zigbee Thread module. If you look at Renfell, they're building RS-232, RS-485, and other IoT connectors. So we are beginning to see a lot of other companies showing interest. And because the spec is already available on mango.io under the documentation section, you can look at it and you can also build for it, and you can post your code on GitHub. Go from there. That should answer that question, Chris.
All right, thank you, Ashish. Our next question for you, as it pertains to security, why not just use Docker to build your sandboxes?
Yeah, so Docker is a quite popular container technology that's used today, largely in desktop and server type systems, especially in servers, because it provides a uniform container kind of socket that you can plug your working systems into. The problem is that it's quite heavyweight, and for an embedded system, it's too much overhead. So what we've developed is an embedded specific sandboxing approach. So it's not complete container per se, such as say the Docker is, but it's very close and moving closer and closer all the time. And at the same time, it doesn't require the huge overhead that most containers do, hundreds of megabytes to get your basic container going. So this one is more on the order of tens of megabytes to have everything going.
All right, thank you. I think that was Ken speaking, right?
That was Jen, sorry.
Oh, Jen, okay. So our next question for you is, how would you decide if if your app should be sandboxed or unsandboxed?
Yeah, I'll take that question again. Essentially, we would recommend that everything be sandboxed. It's a little tricky at times to configure the sandbox permissions. So during development, you may want to start with unsandboxed, and then once your application is up and running, then you can start enabling the sandbox features. On the other hand, sometimes it can be easier to deal with sandboxing permissions one at a time, and then you may want to start in a sandbox and go from there. It's personal preference, but at the end of the day, when you ship the product, we'd like to see everybody using sandboxes for everything, because otherwise we're in a situation where if someone does hack in your particular application, let's say you're running in your application an embedded web server, and someone finds a zero-day exploit in your web server software, and they manage to get it to execute arbitrary code. As I'm sure many people have seen in the news, this happens quite often. If it's in a sandbox, the malicious code is contained within the sandbox. It cannot do any damage to the rest of the system. So we feel strongly that sandboxing is a vital layer of security that should be in all embedded products, especially as the IoT explodes and becomes in charge of a lot of critical infrastructure in our day-to-day lives. We're also working on tools for making the configuration of the sandbox permissions much, much easier, and you should expect that in near release future.
All right, thank you. Our next one for you, will the documentation you provide also include equipment or parts, et cetera, that are needed to try it?
Yes, so if you go to Element 14's website and if you get the Mango dev kit or the starter kit, you should have all the components you need to go try this platform out. And in fact, if you put your own SIM card, we also provide you documentation as to how to align it to the carrier in your region. So from that perspective, yes, we provide you all the information. We have a very clearly written out getting started guide that you can use to get started on this platform very quickly.
All right, thank you, Ashish. The next question for you, please provide more information on the choice of QSFP. Is it designed for fiber ports and other high-speed interconnects? And what's the benefit for low-speed devices? Also, what's the cost of the connector on the host board?
Like all other questions, this is also a very good question. So why we picked QSFP Plus connector was we wanted to have an interface that you can not only slide into the platform. There are instances where you want to screw the board or screw the IoT board using the QSFP Plus connector. So it allows you to not only slide the connectors, but also screw it on your platform if you want to use it like that. So that's the reason we chose this over, say, the other connectors that were available. Yes, it provides us the ability to give very high-speed data, so up to 26 gigabit per second, but that is not what we're targeting with our applications. We were going for lower-speed applications, and so we do not see any potential negative effects of using this QSFP Plus connector. In fact, we found that when we're using high-speed SDIO or USB, the connector was performing very well. The cost of the connector today is something that you will have to work with your distributor and come to the exact cost. From our side, we found it to be pretty cheap when we use it on the Mango platform, relatively cheap, I would say. So it's somewhere in the low to mid end of the connectors that you will normally find. The reason also to use it was because it's been around since 2002, 2003, and it's being used in the Cisco standard for high-speed optical systems. It was easy for us to get it, and there's a lot of connector companies out there that are actually making this connector.
All right, thank you, Ashish. Our next one will be, how would Legato be distributed, and is it portable to other Linux-based hardware platforms?
Yeah, it's definitely portable to other Linux-based platforms. Mentioned earlier, somebody else has already ported it to another embedded platform. I think it was a Freescale IMX something or other. And we actually run it on our desktop PCs as well as a way of running our automated tests. It's distributed through GitHub. So actually, you can go to legato.io today, and you'll find links to the documentation and the GitHub website as well.
All right, thank you, Jen. Our next question here, with Air Advantage, do we have to use Sierra Wireless server, or can we use our own?
You can use your own, for sure.
All right, very good. Next question for you here. Just to check if Legato comes with the purchase of Mango Green. So do you get Legato free with the purchase of Mango Green?
So I think both me and Jen can answer that. So Legato is an open source framework that we provide. It is free. If you go to legato.io, you can download the source code for all the APIs. It's free of cost. Mango Green is a hardware reference design which is now being sold by Element 14. So you get that board, you go to mango.io, it gives you documentation as to how to get started. If you go to legato.io, you can look at all the APIs and source code that we provide. And also we provide a number of applications written on using Legato framework. So Legato is almost like free, if that's what you want to call it, because it's an enabler that allows applications to be developed.
Yeah, it's free whether you buy Mango or not. But I think maybe to answer your question, when you get a Mango with a Sierra Wireless module on it, it does come with Legato pre-installed on it.
All right, thank you, Ashish. Thank you, Jen. Next question here. Project Mango is really a really cool open hardware ecosystem. All specifications are available, but for a fully open hardware product, is Sierra Wireless's microprocessor specifications, are they going to be public?
So to answer that question, so the CF3 module specs are available from our source.sierrawireless.com. Sierra Wireless has to maintain this standard because as we build multiple modules over a period of time, it is very easy for others to be building them. You can do that, but if you build a platform without the right interfaces, it might not work properly. So yes, you can download the specification. If you want to build your own, you could, but where Sierra Wireless adds a lot of value is that we strictly maintain the specification. We have a committee that looks at every module we make and make sure it meets all the requirements and is done, I would say, at the highest quality and standard. So yes, you can download the spec, but I think for the best possible module quality, Sierra Wireless has a long-standing, I'd say, history of doing so.
All right, thank you, Ashish. Looks like our next question, I think you might have already touched on this, but they're asking, how much would the board cost?
Today, if you go to Element 14, you should be able to buy the board based on the region in which you are. So I think that would be the way to look at it. So based on which part of the world you are, there's an additional charge for shipping as well. So I would recommend that you go to Element 14's website to find out the exact cost for your region.
All right, thank you, Ashish. Looks like we have just one more question. Last question here. Is a carrier data plan required to test or trial your solution?
No, you don't have to need it. You don't need a carrier data plan. In fact, you can take a SIM card from your phone, put it on the Mango Green platform, and test out the solution itself. So you don't need a specific carrier or data plan to test out this solution.
Yeah, and certainly if you don't need to use cellular, then you can, like, for example, the Mango Green also has an Ethernet port on it and USB, so if you use that to connect to your network, then you can get going and actually test even IoT applications just using your Ethernet connection. And then once you go remote, then of course, if you're using cellular to communicate, you'll need a plan for that. But ultimately, to get going prototyping and testing everything, you don't need a cell plan.
All right, thank you, Ashish, and thank you, Jen, and thank you, Ken. That looks like about all the time that we have for questions for today. If we did not get to your question, someone will get back to you via email. And for more information related to today's webinar, please visit any of the resource links available in the green folder icon at the bottom of your screen. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Once again, we'd like to thank you for attending today's webinar, Using Open Source Technologies to Rapidly Build Secure IoT Devices, brought to you by Tech Online, Sierra Wireless, and broadcast by UBM. This webinar is copyright 2016 by UBM. The presentation materials are owned by or copyrighted by Tech Online and Sierra Wireless, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests, Sierra Wireless, Ashish Sayal, Jen Chitty, and Ken Arnold, I'm Chris Keach. We'd like to thank you for joining us, and we hope you have a great day. Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Using Open Source Technologies to Rapidly Build Secure IoT Devices, brought to you by Tech Online, Sierra Wireless, and broadcast by UBM. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green